Hello, we're solving this math paper today. This is 9709, May, June 2022, paper 5-1. We have 1 hour 15 minutes and we have access to the formula booklet MF19. It's a 50-mark paper. So let's look at the threshold before we proceed. The maximum mark was 50. This is component 5-1. So A was at 38. B was at 33. C was at 27. D was at 21. And E was at 16. Alright, so let's begin. Also, if you like the content, remember to subscribe to the channel. So also I'm going to be doing all the math papers for the Major 2022 series. S1, M1, P1 as well as P3. Okay, so keep your eyes on the channel if you want those. Also, non-exact numerical answers should be given to 3 significant figures or 1 decimal place for angles in degrees unless a different level of accuracy is specified in the question. Alright, so let's begin with question number 1. Okay, so find the number of different arrangements of the 8 letters in the word deceived, in which all the 3 E's are together and the 2 D's are together. Okay, so how to do this sum? So always, this is the word, right? Write it down. DECEIVED. Now let's put them together. We have 2 D's, okay? We have triple E. Then we have CIV. So to solve the sum, basically, we need the D's to be together. We need the E's to be together, all right? And the CIV, the letters CIV do not need to be together, okay? So how many units do we have in total? 1, 2, 3, 4, 5. So since we have 5 units, it's going to be 5 factorial, okay? Now, the D's are interchangeable, right? So we have a 2 factorial for that. But since they're identical, you can divide by 2 factorial. And you can repeat the same thing for E. So that's into 3 factorial divided by 3 factorial. Because I'm multiplying by 3 factorial because they're interchangeable. But I'm dividing by 3 factorial because they're identical, right? So it's just this. This part was optional. You don't need to write this, okay? So we get a final answer of 120, okay? Find the number of different arrangements of the 8 letters in which the 3 E's are not all together. Okay. What does this mean? So double D, triple E, CIV. This is deceived. So what does this wording actually refer to? Find the number of arrangements in which the 3 E's are not all together. So there are 2 variations of this sum. They could either ask you find the number of arrangements where the E's are not next to each other, and there's another variation where they ask where the E's are not all together. So what do they mean actually? Basically, they're talking about that specific scenario where these 3 E's are actually adjacent to each other. The D's don't need to be adjacent to each other. Okay, they don't need to be next to each other, but they're asking about those specific scenarios where the 3 E's are not all together. Okay, it's different from the E's, you know, being next to each other. That's a different scenario. Okay, we do not have that in this paper. So let's begin. So what am I going to do initially? So I'm going to find out the total number of ways How is that exactly? There are 8 letters, right? So that is 8 factorial divided by, since the 3 is repeat and the 2d is repeat, I'm going to divide by 3 factorial into 2 factorial, which gives us 3360. Moving on to the number of ways with 3 is together. Okay, this is a very specific condition. It's kind of like part 1, but we don't need to consider the d's. Okay, so we have 1 unit over here, 2 units here, 3 units here, so in total 6 units. So that's 6 factorial. Okay, divide by 2 factorial because the dr repeats, into 3 factorial by 3 factorial. This part is optional, I'm reminding you guys. So that is 360. So what is the final answer? Therefore, number of ways with 3 is not together, that is actually 3360 minus 360, which is 3000. Okay, so that's our final answer. So that was straightforward. I'm going to talk about the 3 is, not being next to each other in another video. If I do get that, I'm going to link this on the top so you can follow that if you want. But that's a different method where we have to use arrows, the arrow method, alright? If the question was where the 3's are not next to each other. So there are 6 men and 8 women in a book club. Okay, interesting. The committee of the club consists of 5 of its members. Mr. Lan and Mrs. Lan are members of the club. In how many different ways can the committee be selected if exactly one of Mr. Lan and Mrs. Lan must be on the committee? Okay. So what if I take Mr. Lan? Okay, I've taken Mr. Lan, but exactly one. We can't take both. Now we have 5 men and 8 women, so that's 13 people in total. Right, 13 people in total. Basically, you guys need to understand how this sum works. The wording is a bit different. So basically, if you take Mr. Lan, you can't take Mrs. Lan. Similarly, if you take Mrs. Lan, you can't take Mr. Lan. Also, you can't take both of them at the same time. Okay, that's another criteria. Okay, you can't take both of them at the same time. So let's begin. So what if I take Mr. Lan? What does that mean? Basically, I've taken 1 man, so we have 5 men, but I can't take Mrs. Lan, right? So 1 is missing from here. I can't take Mrs. Lan, so I can choose from 7 women. So that's 12 people in total. So out of those 12 people, I was supposed to choose 5. I've already taken 1 person, right? So I'm gonna go for 12C4. You guys get it? This committee has Mr. Lan, but no Mrs. Lan. Okay. The other one is, what if I take Mrs. Lan, right? So I have 7 women from whom I can choose from, and I can't take Mr. Lan, so 1 man needs to be excluded, right? So I have 5 men. So it's going to be 12C4 again. So it's basically 12C4 times 2, which is 990. There was an alternate way to do this sum. You can learn this if you want to. Basically, what's the total number of ways of choosing people? There are 6 plus 8. There are 14 people in total. So it can be 14C5. This is the total number of ways of choosing the book club. Now, 2 instances need to be excluded. Which ones? the scenario where both of them are in the committee and the scenario where neither of them are in the committee, because exactly one of them have to be in the committee, right? So that's the scenario. So what if both of them aren't in the committee? So I'm going to get rid of Mr. Lan as well as Mrs. Lan. So out of the 14 people, I have 12 people. So out of those 12, I'm going to pick 5. And the other scenario is where I take Mr. Lan as well as Mrs. Lan. So I've taken 2 people already from the 8. Now I can choose 3 more from the remaining 12. So it's going to be 12C3. So this is with Mr. plus Mrs. Lan, and this is without Mr. plus Mrs. Lan, and this one is the total number of ways. So that gives us an answer of 2002 minus 220 minus 792, which is 990. Okay, that's the other way. Next, in how many different ways can the committee be selected if Mrs. Land must be on the committee and there must be more women than men on the committee? Okay, okay. So listen, guys. We have 5 members in total, you know. So women, men. So there must be more women than men. Okay, so the possible combinations are 3 2, 4 1, and 5 0. There's no other way. This is it. Okay, so let's go for it. Also, Mrs. Land must be in the committee. Okay, you guys need to ensure that. So we're always gonna pick Mrs. Land. So let's begin. I'm gonna go with. Oh, okay. So in the mark scheme, they did like this. So what if Mrs. Land is included already? So we're gonna pick 4. We have 4 to pick from. 4 plus Mrs. Land. We've already taken one woman. Okay, we've already taken one woman. Now we can choose from the others. So it can be 4 women and 0 men, or 3 women and 1 man, or 2 women and 2 men. But women are the majority because we still have Mrs. Land, right? Okay, so in total we had 6 men and 8 women, right? Out of which I've taken Mrs. Land already. So we have 6 men and 7 women. Okay, so let's begin. So the first one is um, this one, where we have 3 women and 2 men, including Mrs. Land. So it's going to be 7C2. We've taken Mrs. Land, so we're going to take 2 other women, and we're going to take 2 men. So 6C2. This is Mrs. Land plus 2 women plus 2 men. Okay. The next one is 7C. I'm going to take 3 women, 4 women now in total, including Mrs. Land. So 7C 3 times 6C1. This is Mrs. Land plus 3 women, okay, plus 1 man. And the last one is just 7C4, and you can go for 6C0 if you want. That this is just Mrs. Land plus 4 women, okay. So we get 315 plus 210 plus 35, okay, which gives us an answer of 560. Hope you guys get it. If you do have any other questions, please comment below. Okay, for number 3, we have a histogram. All right, so let's begin. The time taken to travel to college with 2,500 students is summarized below. So what do we need, guys? We basically need to form a table based on this. Do you want a better shape? Right. Happy. Okay. So we need the class width and the frequency density. Okay. So the class width is basically, you need to look at, if you look at the classes first, if they're continuous, they are. So it's just the upper bound minus the lower bound. 20 minus 0 is 20, 30 minus 20 is 10, 40 minus 30 is 10, and so on. 60 minus 40 is 20, 90 minus 60 is 30. Okay. So what about the frequency density? Frequency density is basically frequency by class width. Okay, so the frequency for the first one is 440 divided by 20, right? So like this, you have to continue like this, 440 by 20, that's 22. So if you do that for the others, like 720 by 10 is 72. You guys know it. So we get this 9215 followed by 4. Okay, great. So now we have to give the scaling. So proper scaling should be like this. Uh, we have a maximum value. Frequency density goes on the y-axis. Okay, and the class will go on the x-axis. So we have a maximum value of 92. Okay, so you can go for like one small box is equal to 10. That should work. So this is your frequency density, and below is the time taken. What was the unit? Minutes. Okay, so let's go. Okay, so the scaling, right? 20, 40, 60, 80, 100. This looks good. What about the x-axis? It's still 90, right? The same thing should work. 20, 30, sorry, 20, 40, 60, 80, 100. That's great. Okay, so the first class, 0 to 20 is 22. So this is basically 30. So 22, each small box is 2 units, right? So 22, 0 to 20 is 22. This is the first one, followed by 20 to 30 is 72. 20 to 30 is 72. This is 30. This is 70, right? So 72 is here. You can draw this with your scale. It's going to be easier for you guys. 20 to 30, right? It's like this. Okay. Next, 30 to 40 is 92. 30 to 40 is 92. This is 90. So 92 is over here. Next, 40 to 60 is 15. Okay, so this is 10. 15 should be in the midpoint over here. So 40 to 60 is 15. Like this. You have your scale, it's going to be easier for you guys. And 60 to 90 is 4. So that's just 2 boxes. 60 to 90 is 4, like this. Okay, there you go. This is what it should look like, and the answer is also in the mark scheme. They've provided it, so that's good for you guys. So don't forget to label the axis, and you need proper scaling. Okay. From the data, the estimate of the mean value is 31.44. Calculate an estimate of the standard deviation. Okay, how many questions do you have in total? Okay, 6. Let's continue. Calculate an estimate of the standard deviation. Okay, so what do we need for the standard deviation? Firstly, we need the midpoints, okay, of the classes, since it's an estimate. So it's basically the midpoint is like this: lower bound plus upper bound by 2, which is 10, right? So this is 10, okay? This is 20 plus 30 by 2, 25, 35, 50, and what is this exactly? 60 plus 90, 75, I guess, right? 60 plus 90, by 275. Yeah, these are our midpoints. Okay, now you guys need to understand something. What is the formula for standard deviation? It's basically root over variance, right? And what is the formula for variance? Variance is basically the summation of x square f divided by n minus the mean whole square, which we have. So it's a summation of x square f, where f is the frequency, and for a histogram or a cumulative frequency graph, the value of x is basically the midpoint that I've written here. It's basically the midpoints. Okay, so let's see. So let's begin. So x square f, that's basically 100. You gotta show it to them though. So it's basically 10 square times 440. Okay, so yeah, times 440 plus the next one was 25 square times 720. Next one was 35 square times, what was it again, 920, then 50. Okay, so 50 square times 300 plus 75 square times 120. So these are the values. Divided by the total frequency was 2500. N is basically the total frequency. Okay, sorry, minus 31.44 whole square. So it's best if we show all the steps. So that's 44000 plus 450000 plus 1127000 plus 75000 plus what's the last one? 675000. Okay, should match by 2500 minus 31.44 square. Okay, now what? If you add it up, you get a value of 3046000 by 2500 minus 31.44 square, which gives us a value of 229.9264. Okay, now we need to find out the ST. So the standard deviation is root over variance. So root over your calculated answer, 229.9264. So the answer to three significant figures is 15.2. Okay, that's it. In which class interval does the upper quartile lie? Okay, so Q3. So the total frequency is in fact 2500. Let's write down the cumulative frequency. 440. 440 plus 720 is 1160, plus 920 is 2080, plus 300 2380. Okay, plus 120 is 2500. So the upper quartile is basically 75%, of the cumulative frequency. So 75 by 100 into 2500 is 1875. Okay, so the upper quartile essentially lies or is the 1875th value. So where does that lie? So the one there are 1160 values still 30, and there are 2080 values still 40. So 1875 clearly lies over here, right? 1875 lies here. It is greater than 1160 but less than 2080. So we're gonna go for this class. So we're gonna go for 30 to 40, right? Hopefully that makes sense to you guys. Okay. It was later discovered that the times taken to travel to college by two students were incorrectly recorded. One student's time was recorded as 15 instead of 5, and the other's time was recorded as 65 instead of 75. Without doing any further calculations, state with a reason whether the estimate of the standard deviation part B would be increased, decreased, or the same. Okay. So one student's time was recorded as 15 instead of 5. Okay, so we recorded it as 15 while the original, the one we did in part B, while the original was 5. Okay, and the other was recorded as 65 instead of 75. Okay, so basically, let's try to understand what happened. If you think about the mean, right? For the mean, if you add these two up, 15 plus 65 plus some other values, what's the value? 15 plus 65 is 80, right? Right? And uh, this is the false one, and the original one should be like 5 plus 75, 5 plus 75 plus other values by 2500, that's still 80 by 2500. So the mean doesn't really change. The mean is still going to be 31.44. Okay, the mean is still going to be 31.44. Since 15 should have been 5, that's 10 less, but 65 should have been 75, that's 10 more. Okay, so the mean doesn't really change. So this part doesn't change. Then what changes? This changes. So summation of f doesn't change. But what happened to x square f? Check this out. So x square f, for this one, 15 was recorded instead of 5. 5 should have been here. 5 should have been here, but 15 is also here in this class. Okay, but here's the thing. When we find out an estimate of the mean, I was viewing this in a wrong, from the wrong perspective actually. Basically, we wrote it as, what did we write it as? We we wrote it as 15. Okay, so we wrote it as 15, but it should have been 5, and we wrote it as 65, but it should have been 75. So that doesn't really matter, because even if the 15 was 5, it would still be in this class, and even if 65 was 75, it would still be in this class. But when we found out the mean or the variance, we didn't even use individual values, we just used the mid value. Do you guys understand? So it won't actually change this value or this value either, because they're still in the same class. Like 5 and 15, they're still over here, and 65 and 75, they're still over here. So this value below wouldn't change. 440 would remain as 440, and 120 would remain as 120. So it wouldn't ultimately result in a change in the estimate of the mean or the estimate of the standard deviation. Okay, so we're going to say that it stays the same. Why? Because the data still remains in same classes or same intervals. And what is the consequence? We can say that the frequencies are unchanged. That's that. Okay, when would it change though? For example, if the original value was 5 but we wrote it as 25, okay, then it would be a different issue, because it's in another class. Moving on to 4. Jacob has 4 coins. One of the coins is biased, such that when it is thrown, the probability of obtaining a head is 7 by 10. The other 3 coins are fair, half. Jacob throws all 4 coins once. The number of heads that he obtains is denoted by the random variable x. The probability distribution table for x is as follows. Show that a is equal to 1 by 5 and find the values of b and c. Okay, easy. So let's go for a. What does a mean? A is basically the probability where um, we get one head. So we say px is equal to 1 is equal to a. So how are we going to get one head? For the other three, it's just half, right? So either it's head, tail, 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 or tail, head, tail, tail, or tail, tail, head, tail, or tail, 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 head, where the first coin is biased, okay? So let's go for it. So the first coin is biased at 7 by 10. So for the biased coin, the probability of head is 7 by 10, while the probability of tails is 3 by 10. And for the others, half of each, okay? So 7 by 10 times tails 3 times, okay? This is head, tail, tail, tail. Plus, what about the other one? Suppose we get a tail in the biased coin, 3 by 10. Then we get a head in the second coin and tails in the other two, okay? Then tail again in the first coin, tail in the second one, head in the third one, and then tail in the last one, okay? So you guys get the trend, right? It's half, so it doesn't really matter. So you can just go for 3 by 10 times half cube. It's gonna be the same answer. You guys get it? So can't I write it like this? Basically, a is equal to 7 by 10 times half cube plus 3 by 10 into half cube plus 3 by 10 into half cube plus 3 by 10 into half cube. Doesn't it work like that? Because the same thing is repeating. Or we could go for a is equal to, 7 by 10 times half cube plus 3 by 10 into half cube times 3. Does that work? This makes sense, right? So we can get rid of this working over here because it's wasting space. We have other stuff to do. So basically we're doing this to find out a, and it's gonna give us the answer 1 by 5. So we just proved that, okay? Now what? They want us to find b and c. Okay. So let's go for b. B is basically px is equal to 2. So that's 2 heads and 2 tails. How? Basically head, head, tail, tail. Or head, tail, or head, tail, head. These are the possibilities where the one on the left is the bias coin, or it can be tail, head, tail, or tail, head, head, or tail, head, head. You guys understand? These are the 6 possibilities where I keep the first one head and alternate heads for the 3 coins, or if I keep the first one tail and then alternate tails for the other 3 coins, okay? So it's basically, suppose for the bias coin, if it's heads, that's 7 by 10, right? And that's 7 by 10 here, and basically this is half, this is half, this is half. It's half for each of them, so can't we go for this half cube? So this thing is going to repeat 3 times, so it's half cube times 3, okay? That's how it's done. And what about the other one? This is one scenario. What about the other one? The other one will be, you know for tail it's 3 by 10, and then heads or tails it's always going to be half, so that's half cube, right? So half cube times 3, so that gives us an answer of 3 by 8. And if you want to find out C, C is basically like the summation of this is 1, right? So C is basically 1 minus 3 by 80 minus the value of A, which is half, minus the value of B, which we just found out, 3 by 8, and 7 by 80. So let's find this out. Let's see what we get. 3 by 80 plus 1 by 5 plus 3 by 8 plus 7 by 80. Then 1 minus answer gives us an answer of 3 by 10. So we're getting 3 by 10, okay? Or you could do it manually, is your wish. Next, find out the expectation. So what is the expectation basically? It's the probability multiplied by the value of x. Okay, so let's find out expectation. You got to show the steps. So ex is actually equal to, what's the first one? 0 times 3 by 80. Then 1 times 1 by 5. 2 times 3 by 8. Then 3 times 3 by 10. Then 4 times 7 by 80. So if you do it like this, it's fine. They did something weird. They made the LCM 80. You don't have to do that. They like had a common factor in the denominator. It's fine. You can do it like this. It's totally okay. And if you do multiply, try it. 1 by 5 plus 6 by 8 plus 9 by 10 plus 28 by 80 gives us this answer. 11 by 5. Okay, it gives an answer of 11 by 5, which the road has 176 by 80. This can also be written as 2.2, right? So that's that. So you'll notice that in the mark scheme they mentioned correct or accept unsimplified calculation using their values for B and C. So it's fine. You don't need to do it their way. This way works, okay? Next, Jacob throws all 4 coins together 10 times. Find the probability that he obtains exactly 1 head on fewer than 3 occasions. So this is basically a binomial distribution where success is getting 1 head. So getting 1 head is basically A, which has a probability of 1 by 5, okay? So here success is getting 1 head. So let's write down the distribution. So we can say that, do you guys want to use x? We can use x. X is binomially distributed. X is binomially distributed where you know the binomial distribution, right? N, P, N, P. So it's basically 10 and probability of success. So fewer than 3 occasions. So basically it's Px is less than 3. So what does fewer than 3 mean? It includes 0, 1 and 2 but not 3 because it's a less than sign. Okay, so that is Px is equal to 0, 1 and 2. So let's move on. So this is basically 10 C0. Okay, 10 C0 success to the power 0, failure to the power 10 plus 10 C1 success to the power 1 and failure to the power 9 plus 10 C2 success to the power 2 and failure to the power 8. Okay, so if you want you can mention the individual values. I see them doing this in the mark scheme recently. So 0.107374 plus 0.268435 and 0.301989. I didn't do it during my exam. I still got full marks, but recently this is this has an A1 mark, so make sure you write this as an individual step. So the final answer to 3SF is 0.678. Okay, hopefully I could clarify. Now find the probability that Jacob obtains exactly 1 head, okay, for the first time. So this indicates that this is a geometric distribution on the 7th or 8th time that he throws the 4 coins. Okay, So 7th or 8th time, you know. So this is basically a geometric distribution. We can say that y is geometrically distributed where the probability of success is exactly one head. So that's 1 by 5, right? So 7th time or 8th time. So what does getting success on the 7th time mean? You failed 6 times, right? So basically we can say p y is equal to 7 or 8 is basically the formula is pq to the power, n minus 1, right? So for example, if we want success on the 7th try, we need to fail 6 times, right? So that's 1 by 5 times q failure, 4 by 5 to the power 7 minus 1, which is 6. This is success on the 7th time. Or success on the 8th time, which is 1 by 5 times 4 by 5 to the power uh, you know 7. That means you failed 7 times and then succeeded on the 8th try. So if you do solve this, you get 0 0.0524 288, 0 0.041943. So that's 0 0.0944. Okay, that's all. By the way, geometric distribution was added to the syllabus from 2020 onwards. Okay, now we have 5 and 6 left. So for 5, the lengths in centimeters of the leaves of a particular type are modeled by this distribution. So x is normally distributed 5.2, 1.5 squares. So what about a normal distribution? X is normally distributed where the first symbol is mu and the next one is sigma square, which is basically variance, right? So find the probability that randomly chosen leaf of this type has length less than 6. Okay, so p x is less than 6, right? So less than 6 is the standard. That's totally fine. What do we need to do? We just need to standardize this. So we can say that pz is less than 6 minus 5.2 divided by um, basically this standard deviation, which is just 1.5. Remember that it's not the variance. Could I clarify? It's not the variance. So I standardized it. Now I'm getting, let me do this, 6 minus 5.2 divided by 1.5, which is equal to p z is less than 0.533. They gave another one, but that doesn't really matter because look at the table. Okay, so now we have access to the table. Okay, so this is not going backwards. This is not retrospective. We're proceeding forwards. So I'm going to look for 0.533. 0.5333. So basically, look at how we do it. I am looking at the value of z, so 0.5. Okay, so 0.53. So this value, and then 0.533. It's basically, 0.53, the third dp. So there's another 3 over here. So for that 3, I am going for this value, which is 10. Okay, so it's basically this value, mainly 0.7019, but due to this 3, we need to add this 10 to these last two values, 19. So it's basically 0.7019 plus 0.0010. It's added to the last value, okay, from the fourth decimal place. So 0.7019 plus 0.0010, which gives us a value of 0.7029. Okay, so that is equal to 0.7029, but to 3SF it's 0.703. This is our answer. Okay, next. The lengths of the leaves of fan the type are also modeled by a normal distribution. A scientist measures the length of a random sample of 500 leaves of this type and finds that 46 are less than 3 and 95 are more than 8 centimeters long. Okay, so p x is less than 3 is actually equal to 46 by 500. How much is that? 46 by 500. That is 0.092. So px is less than 3 is equal to 0.092. What about the other one? P more than 8. X is greater than 8 is equal to 95 by 500, which is 0.19. So px is greater than 8 is equal to 0.19. Clear? We need that x is binomial distributed. Sorry, normal distributed. And we don't know the mean or the standard deviation. Those are unknown. Okay. So let's begin. So this is fine, right? This is okay. So we can go for pz is less than 3 minus mu by sigma is equal to 0.092. And here we need to fix this. Okay, we need to fix this. Basically, greater than isn't all right, because you know the table, this is only valid for pz is less than z, small z. So basically, if I draw a normal distribution, the table only works for values less than a certain value. Suppose if this is the value, this is what the values in the table mean. It only represents the area before a certain value. Okay, so we cannot go for this. So we need to fix this. How? 1 minus p x is less than 8. How am I doing this? Basically, I'm given this area over here. I have this area over here, but I want this area on the back. How can I do that? If I subtract 1, if I subtract that value from 1, I'm gonna get the area behind, right? So that's equal to 0.19. So 1 minus 0.19 is 0.81. Okay, so px is less than 8 is equal to 0.81. Okay, now you'll be facing another issue. The first value in the table is 0.5. This is retrospective, we're going backwards. But this is less than, this is actually less than 0.5. So what does this mean actually? This value actually lies behind the y-axis. It's somewhere over here because the area is only 0.09 or 9%. That means the value lies here. So the value is in fact negative. This value over here, this is in fact negative. So what do we do to make a negative value positive really? For example, we do two things in normal distribution. We convert the greater than sign to less than. How? By doing this 1 minus p x is less than x. It was initially p x is greater than x. And the other thing we do is if p x is less than minus x, we can write it as 1 minus p x is less than x. Why is that possible actually? Because suppose if this value is minus x, this value is x, right? So if they told you this px is less than minus x, it's this region over here. According to symmetry, this region would also have the same value, right? This region would have the same value. So what if I did this 1 minus px is less than x? So what is px is less than x? Basically this region. So if I subtract this value, this orange value from the whole region, am I not getting this small red region over here? That is the reason why it's 1 minus px is less than x. Okay, so that is what I'm going to do since this value is in fact negative. So I can write it as 1 minus p z is less than minus 3 minus mu by sigma, okay, equals to 0.092. They don't show the details, but this is what's actually happening. So we end up with pz is less than minus 3 minus mu by sigma is in fact equal to 0.908. Okay, now what? Let's look for these values, 0.81 and 0.908. Let's look. So 0.908, I'm going to look for the value in the table itself. So 0.908, we cannot take this value since it's greater. We're going to go for this value 0.9066. So 0.908 minus 0.9066, what's the difference? 14, right? 14. So I'm going to look for 14. I do have 14, so I have winner. So basically this value is 1.3 1.32, and the value over here is 9. 1.329. Okay, it matches exactly 1.329. So I'm going to go for this. Minus 3 minus mu by sigma is equal to 1.329, or 3 minus mu by sigma is equal to minus 1.329. Okay, what about the other one? 0.81, right? 0.81, 0.81, look for it. The rule is you can't look for a value which is greater than 0.81, but the closest one. 0.81, this is greater, this one, 0.8078. So 0.81 minus 0.8078. Okay, so I need a value of 22. Do I have 22? I do. So it's basically 0.8, 0.87, 0.878, 0.878. Okay, 0.878. So that's basically, oh, I didn't standardize it, did I? So Pz is less than 8 minus mu by sigma is equal to 0.81, or 8 minus mu by sigma is equal to 0.878. Okay, so that's that. Now let's do this. 8 minus mu is equal to minus 1.329 sigma, and sorry, 3 minus mu, and 8 minus mu is equal to 0.878 sigma. Okay, now let's solve them simultaneously. Minus 8 plus mu is equal to minus 0.878 sigma. Okay, we can get rid of these. So minus 5 is equal to minus 1.329 minus 0.878. 1.329. That's minus 2.207 sigma. Okay, so 5 divided by answer is sigma is equal to, sorry, my sigma looks like a 6. So sigma is actually equal to 2.27 to 3SF. Okay, this is 3SF. And what about mu? So 8 minus mu is equal to 0.878 times 2.27. I'm using my calculator answer though. Okay, 2.878. So I'm getting a value of mu is equal to 6.01 to 3SF. Okay, these are my answers. All right. Okay, so for the next one, we have, in a random sample of 2000 leaves of the second type, how many would the scientists expect to find with lengths more than one standard deviations from the mean? Very, very important question. What does this mean? So basically, we have 2000 leaves of this second type, this one that we just figured out. So the distribution is, suppose y is normally distributed with a mean of 6.01 and a standard deviation of 2.27, which is, we need to write the variance 2.27 whole square. Understood? Okay, so suppose if this is your arrangement, the mean is over here, the graph is like this. Okay, so they are asking you, how many would the scientists expect to find with lengths more than one standard deviation from the mean? So this is basically the mean, right? So check this. What if we had 6.01 plus sigma, and what if we had 6.01 minus sigma? Isn't that basically one standard deviation above the mean and one standard deviation less than the mean? So the scientist basically wants you to expect, like, find lengths greater than and less than this mean. Okay, so basically not this region, because this is within one standard deviation within the mean. Basically the scientist wants you to find out this region. Okay, and then you need to multiply that probability with you know by multiplying it with the number of leaves 2000. All right, so we need a table for this actually. But so they basically want that region, right? So let's go for this. So how are you going to approach this? It's 1 SD from the mean, right? So for example, since I named the distribution Y, it's going to be P, um, the section in between. I'm gonna write that first, the section in between. So that's P Y is less than 6.01 plus sigma minus P Y is less than 6.01 minus sigma. What am I doing essentially? Basically, if this is the diagram and this is 6.01 and these are our two ends, basically the first one, this one over here, this is this area, and the second one over here, this is this area. So if I subtract that, I'm gonna get the orange area in between, right? If I subtract that, I'm gonna get the orange area in between, which is this basically. Okay. But do we need this pink area in between? We actually need the area that's outside over here. The blue area is shaded over here, right? There was an alternate way in which you could do it. I'm going to show you the other one. So this is giving us the pink area. So if we subtract the pink area from 1, we're going to get the area externally over here and here, right? That's what we're getting essentially. Okay, so the one I wrote here is the pink region, but if you want the blue region, you have to subtract this whole value from 1. Okay, then we're gonna get the region that we want. There was an alternate way. I'm gonna show you that as well. Okay, so let's standardize this, shall we? So let's go for it. This is 1 minus p z is less than 6.01 plus sigma, you know, minus 6.01 divided by sigma, right? Minus p z is less than 6.01 minus sigma minus 6.01 divided by sigma. Okay, so we actually end up with 1 minus p z is less than, we can get rid of these, so that's sigma by sigma, which is essentially 1, minus p z is less than minus sigma by sigma, which is less than minus 1. Make sense? Now what? If you break down the brackets, you get 1 minus p z is less than 1 plus p z is less than minus 1. Okay, but we have to get rid of minus 1 as well. So how do you do that? I just taught you. It's 1 minus p z is less than 1. So that's 1 minus p z is less than 1 plus 1 minus p z is less than 1. Okay, so if you break down the brackets, finally you get 1 minus p z is less than 1 plus 1 minus p z is less than 1. So we end up with 2 minus p z is less than 2 minus 2p z is less than 1. Okay, so now what? Basically z is less than 1. What does that mean? We have the table. So 1 basically means a value of 0 0.8413, 0 0.8413. So this is basically 2 minus 2 times 0 0.8413. 2 minus 2 into 0.8413, which gives us a value of 0.3174. So if you want the final answer, that is the number of leaves, right? If you want the number of leaves, what do we need to do? Basically, multiply this probability with the number of leaves. So 0.3174 times 2000 leaves, which is 634.8. Okay, you could write this as your answer, but not really. Basically, you should round it off to 635. Okay, 634 would be accepted as well, since all non-exact answers should be given to three significant figures. So that's that. Okay, so this is one way of doing it. The other way was, if you guys are interested, you could do it manually. For example, you could go for um, going for the blue areas individually. For example, if you want to go for area number 1, you could go for P y is less than 6.01 minus sigma. That is this region. This is the pink area. And if you want to go for this area over here, area 2, that would be plus 1 minus P z, sorry, y is less than 6.01 plus sigma. Basically, what am I doing? I'm finding this one out. This region is this part. So if you subtract that from 1, you're going to get the blue region. Okay. So that's P z is less than 6.01 minus sigma minus 6.01 by sigma, which is minus 1, right? Plus 1 minus P z is less than 6.01 plus sigma minus 6.01 by sigma, which is just 1. So if you do break this down, you end up with 1 minus P z is less than minus 1 plus 1 minus P z is less than 1. So if you add them up, you get the same thing, 2 minus 2P z is less than 1. Okay, so that's the same thing. That's the same thing. All right. What about the last one? Janice is playing. Okay, so you could opt for both ways if you wanted. Okay, both work. The one on the left is just a bit more complicated. Plus some. Janice is playing a computer game. She has to complete level 1 and 2 to finish the game. She is allowed at most 2 attempts at any level. For level 1, the probability that Janice completes it at the first attempt is 0.6. If she fails at her first attempt, the probability that she completes it at the second attempt is 0.3. If Janice completes level 1, she immediately moves on to level 2. For level 2, the probability that Janice completes it at the first attempt is 0.4. If she fails at her first attempt, the probability that she completes it at the second attempt is 0.2. Show the probability that Janice moves on to level 2 is 0.72. Okay, so let me draw the tree diagram for you guys. Okay, so this is the first level, first try. Okay, so either she's gonna succeed or fail. So success in the first level is 0.6, so failure is 0.4. If she fails, she's going to repeat the first level again. Okay, but in the second attempt, the probability that she succeeds is 0.3 and fails is 0.7. Okay, this is the second try for first level. Okay, wait, let me write this here. It will be better for you guys. So 0.6 and 0.4, 0.3 and 0.7. So if she does succeed, then she moves on to the second level, right? This is the second level. This is the second level. So completing it on the first try. So completing on the first try is 0.4 and failing is actually 0.6. So if she fails, she can go again. Second level, second try, success and failure. The second try, she succeeds is 0.2 and this is 0.4. I mean 0.8. Okay. And what if she succeeded the uh, on the second try of the first round? She can proceed. She can proceed to the second level. First round, first try, I mean. So second level, but first try. So for the first try, success is zero point 0.4, failure is 0 0.6, and if she does fail again, she can try again. This is the second try for the second level, success and failure. This is 0 0.2 and 0 0.8. Okay, interesting. So this is it. Now show that the probability that Janice moves on to level 2. So where is she moving on to level 2? This is one route, this is the other route of moving on to level 2, right? So I've marked them with black. So one way is, you know, succeeding on the first try or succeeding on the second try of the first level. That's it. That's all. Okay. Those are the ways you could move on to the next level. So that's basically zero point 0.6. This is succeeding on the first try, or you could go for failing the first try and then succeeding on the second try. And this results in an answer of 0.72. What about the next one? Find the probability that Janice finishes the game. Okay, so to finish the game, she needs to complete the whole thing, right? So this is one route. This is one route. This is another route. This is another route. This is another route. So there are 4 ways in which she can ultimately succeed. So there's a complex way in which you could do it. Like if you considered all individual branches, that would be very time consuming. The easier route is just find out where it ends, you know. For example, if you consider this one over here, if you consider this over here, basically after this you will succeed. Ultimately you will succeed, you know. Okay, for if you do stop here, okay, I'll show you the manual route, but you guys need to understand, to finish the game you need to succeed in both rounds, right? So this is an interesting question. So they're asking, find the probability that Janice finishes the game. She has to complete level 1 and 2 to finish the game. Okay, at most 2 attempts at any level, right? So success followed by success, this is one. Success, failure, success, or failure, success, success, or failure, success, failure, success. These are the 4 routes that we can go for. Okay, so let me do them individually. So success, success, that's 0 0.6 times 0 0.4. Okay, next one is success followed by failure followed by success. Next one is failure followed by success again. Or what's the next one? Failure followed by success followed by failure again, and then the last one, success, 0 0.2. So if you do find this out, 0.6 into 0.4 plus 0.6 into 0.6 into 0.2 plus 0.4 into 0.3 into 0.4 plus 0.4 into 0.3 into 0.6 into 0.2. That gives you an answer of 0.3744, or it's 0.3742, 3 significant figures. But this is an exact answer, you know. So if you do write 0.374, you're going to lose a mark. Since this is exact, you should keep it this way. Could I clarify? So what's the alternate way in the mark scheme? How did they do it the alternate way? It's basically 0.72 into zero point 0.4 plus zero point 0.6 into zero point 0.2. This is interesting. This is the alternate way in the MS. So what does this mean? 0.72 is the probability that you move on to the second stage, right? So 0.28 is the probability that you fail the first stage. So if you multiply the probability of passing the first stage, basically this is the chance of passing the second stage. Sorry, the first stage. So what about the second stage? So we all, in that method, they already stopped here. Basically, they stopped here and here. They stopped here. Now they thought about it, like what could happen afterwards. Okay, because this is what 0.72 means. You have passed the first stage already. Now you're moving on to the second stage. Okay, so afterwards, what did they think? A few possibilities were present. What were they? One possibility is this path. Like afterwards, you could go for this. Basically, afterwards you could go for this. You win, or you fail, then win, or you directly win in the second in this route. So there are three routes basically. So it's basically zero point 0.4, right? Basically zero point 0.4 in this one, or zero point 0.6 multiplied by zero point 0.2. Okay, so that's zero point 0.4. Wait, let me show you. So it's zero point 0.4 plus zero point 0.6 into zero point 0.2. Or you could go for this route, right? You also have access to this route. So that's basically for, like, if you split it individually over here, what if the chance of succeeding the second round? What if you were asked to find that out? What would you go for? You would go for, you either succeed initially, like multiplying with zero point 0.4, or the other route is zero point 0.6 times zero point 0.2, you know? So this is the chance of succeeding in the second round. Do you guys understand? 0 0.4 plus zero point 0.6 into zero point 0.2. So basically, succeeding in the first round was 0.72, and then succeeding in the second round is basically zero point 0.4 plus zero point 0.6 times 2, right? For each of them, above and below. So if you multiply these two, you will also get your answer of 0.3744. So yeah, it's a bit difficult to comprehend, but if you can do it manually, it's fine. But if you want to understand this, that's also okay. This is also an easier route. Okay, we already got this in part one, succeeding in the first one. So succeeding in the second round is basically this blue part. I'm completely ignoring the black part over here. Like, what was the probability of succeeding? 0 0.4 plus zero point 0.6 times zero point 0.2. So if you multiply them, you get the answer. Okay, now last one. Find the probability that Janice fails exactly at one attempt, given that she finishes the game. So this is the condition. How do you write it? Probability that Janice fails exactly one attempt. What does that mean? She fails first or second level. Okay, and what is the condition? She finishes the game. Okay, so the condition will always go to the denominator, and the numerator must be a part of the denominator. Okay, so this was success, success. This was success, fail, success. Okay, this was fail, success, success. This was fail, success, fail, success. Okay, so finishes the game. What's the probability for that? Basically, the denominator will be 0.3744. What about the numerator? Fails exactly one attempt. That means we cannot go for this. We cannot go for this because it has two fails. We'll go for this one and this one because there's only one fail over here, right? So 0.6 times 0.6 times 0.2 plus zero point 0.4 times zero point 0.3 plus zero point 0.4. Sorry, zero point 0.4 times zero point 0.3 times zero point 0.4. Okay, let's find this. 25 by 87, exactly. 25 by, sorry, 78. Or you could write, since it's irrational, you could write 0.321. Anything works, okay? So guys, that's all. Hopefully I clarified the paper. So I'm going to be doing the other S1 papers as well. So when I'm done, I'm going to link May-June 2022 variant 5.2 up here and May-June 2022 variant 5.3 down here. And I'm going to link the playlist for S1 up here. And remember to subscribe to the channel if you like the video. See you guys.